Okay, children, a few things. Please look up. You'll have to do your warm-up in a minute. I'm going to go pee, so you'll have a second. Are there any Unit 7 makeups left even now at this point? Any last Unit 7 makeups at this point? Anybody who still needs to present their solar house model or who'd like to appeal and re-present their solar house model, we're going to do that during the block day. I know that I said yesterday that we would do it today. I've had to make some adjustments in the planning for this unit. I'm sorry, I'm going to push it off until tomorrow. If you cannot carry that rolled up paper with you anymore, you're welcome to leave it here. The one problem is I can't supervise that paper. You understand what I mean? That if another student walks away with it, I would never know. So if you're willing to roll the dice, you're welcome to leave it here. You can put it on top of that aquarium. If you label it with something fairly obvious, I'm hoping that nobody would mistake it for another. You could use different color Post-its if you'd like. I want to be helpful. So if you need to leave your stuff, here's Post-its. Me, excuse me, Pete. Here's Post-its and here's paper clips. If you wanted to leave them here, pay at your own risk, but that might work. The Unit 8 plan is posted. If you have questions, I'll answer them after IP. And today we're going to do something exceedingly unusual, and I'm pretty sure it'll never happen again. I'm going to do your homework for you. The first part of assignment 8.2. So you'll need blank paper and the study guide. Finish your warm-up. Deal with your poster paper. After IP, I'll come back to help you. We're going to do some of Unit 8.
That's it's a type of pot used to brew coffee by continually cycling, boiling or maybe boiling through the grounds and gravity. So the requires it just boils the water.
cost right now to go past. Oh,
Before we get too far, yes?
I don't have the, yeah. Yeah, they were correct.
Thank you for checking. I appreciate that. Before I start, oh my God, I feel cell phone. Maybe it would do something to the spelling if like it would do work. Cell phone.
Can I put these again?
Try. If it helps with the cell phone situation, it would be my pleasure. Or you can put it in your backpack and we're not a problem. I don't like to do this. In terms of practicality, I'm not a big fan of just like talking at you and you writing it down and considering that to be your sole learning. Pedagogically, like I could never argue that that's the most successful method. I really do believe, like philosophically and professionally, in that idea of you getting most of the content out of the book and conversation being the second pass. Empirically, we know you learn better by reading it than writing it, than hearing it, than writing it, than saying it. So this is not the way that I would choose to run our classes, but in this unit I kind of have to. Because you know that we usually start with a movie, which lets the kids do the makeup test, and lets me work at my desk for a day, and gives you a free class day before you have to bring your own notes so that there's 2 nights for you to complete the homework. It's all part of the system that I have that I'm really happy with. Anyway, I can't do that today because I gotta save my movies for the last week in case I cannot attend. There should be a movie this week. We know we have Thursday covered. Stay tuned. We still don't know if we have Wednesday covered. You need someone. It's not going to be the Patagonia movie. We're showing Flow on Wednesday and Tapped on Thursday. They're both movies about water crises, water management, water politics. So they're both kind of like liberal propaganda movies. What? They're 2 separate films. One on Wednesday. What? Oh, no, not very. I would say, yeah, you could see them both for 2 points of credit. Yeah, I haven't even gotten them out yet. I'm going to say that they're in the last decade, but I don't know exactly what year. How about you can find them later if you want that question answered? TAP won like 5 Best Documentary Awards. 2010. Flow was in Sundance, but it didn't win. Wasting so much time to answer your damn question. 2008. So it's like water infrastructure, water policy. What do you call those things? The little crusts, the little like feathers? Yeah, well, it means that they were entered. A lot of times really closely, it's like worst entry in the Jose's Toilet Award. And like they're not a big deal. But what do you call those? Those little crevices. It it pains me to do this, but here we go. Most of the vocab in this unit is also covered in study goal number 11, so we can skip the vocab, and if you want to make it a separate page later, that would work. Or blend it into your notes. My TAs will probably trust you. However you want to manage the vocab in this particular assignment, I understand it might get kind of freaky. It's a lot of vocab, but it's all words that you know, like these. Please look up. Does anybody remember from first grade or maybe kindergarten, the water cycle song?
Yeah.
Evaporation.
Hit it!
Evaporation, condensation, condensation, runoff.
You're so much happier during this period.
I know that.
Why are you such a...
You're such a teddy bear in this mess.
I was talking about you though.
I know. It's the early morning.
Good. First of all, vocabulary terminology that you maybe don't know. This is the third grade version of the water cycle song. Evaporation is when water evaporates from the surface of some sort, while transpiration is a vocab term, evaporating from something that's alive, like a plant or an animal. Okay, I'll try that again. Evaporation is when water becomes water vapor from a surface, like a lake or the top of your car, or Leah's lifeless body. Right, because I would have bludgeoned her with my chopstick. And transpiration is evaporation from something that's alive, like a plant or an animal. Yes, would that be like sweat? Yeah, that's in Spanish. Transpirar is how we say sweat. That's exactly what it means. Yes, it's evaporation from something that's alive. Now that it's water vapor, everybody knows that it will condense, but vocab term at the apes level, it doesn't just happen on its own. Water vapor doesn't become droplets in a vacuum. Condensation nuclei, like plural of nucleus, condensation nuclei, vocab term, are little flecks of stuff in the air that condensation can form on. Does anyone know why condensation needs matter to translate from vapor to liquid? It's a simple physics term that I think you all understand once we say it. Yeah. Why couldn't they bind to each other in the air? Think of what makes them vapor and what makes them liquid, what the difference is. That's right. And so water molecules in vapor form need a substance to give their energy to so that they can slow down and grab onto each other and make a liquid. Condensation nuclei are that thing. That's why if you leave a bucket out and it's filled with rainwater, that bucket will become a pond with a Loch Ness monster. If you've ever left a jacuzzi uncovered in the rain, you know it can get really funky. If you've ever left the dog bowl out for a couple days where the dog couldn't get to it, it'll get pretty funky with rainwater. It's also true, I'm sure you know, that the wind will blow life into water. So if this thing was just full of tap water, the wind-blown dust and crap would eventually make that lively. But a bucket of rain, if you cover it up right after the rain, will still get pretty funky, even if you preserve it from air-blown stuff, because every raindrop has something in it. Dust, ash, spores, pollen, and single-celled organisms. Rain literally carries life. And you might remember this came up in the past when we talked about primary succession. Who remembers primary succession? Where soil is formed on a lifeless medium? A lot of people mistakenly suggest that erosion builds soil, but that's wrong. Because erosion makes rock into smaller rocks, which we call sand. The life can be born by wind, but is certainly carried in rain, every raindrop. I don't know about you, I kind of find that neat. Just a little check of previous knowledge. How many of you have heard of seeding rain? Those words, seeding, rain seeding. Or snow seeding, perhaps? So you can make special jet fuel that's really smoky. It makes really, really, really fine ashes. And you fly through high moisture air masses, provide condensation nucleus, and it starts to rain behind the airplane. It's called seeding rain. You can also shoot rockets into the lower atmosphere that explode in clouds of very fine stuff, sort of like a flower explosion in your house, but it's not flour. And it makes rain, and that rain falls. How many of you have heard of a rain dance? It's for real. Not every time. It's not how you do or what the dance or whatever. But does everybody know what a mesa is in the desert? A mesa, that's Spanish for table. It's like an elevated flat surface in the desert. You understand what I mean? So imagine if you've seen that one thing in Idaho, the Devil's Tower? Idaho, is that what it's called? It's a movie about aliens that's really famous. Old movie with the directors. Who would know? Anyway, desert, mesa, wherever the wind is blowing, wherever that wind is blowing, it'll make an updraft on the mesa, correct? If there's a wind. And you all realize that preceding a rainstorm, there is always a wind. As an air mass is moving in, it's either a cold front creating a wind in front, or warm front sucking wind into it. Are you aware of that? Cold front and warm front have different winds? Mesa. Dancing grows. Whichever way the storm is coming, it's going to make a wind. Either a cold front wind or a warm front wind. You get the homies up on the mesa. You kick up some dust, and the updraft will carry it presumably as high as the high moisture clouds coming over, and that makes them start raining. It takes a lot of dust. You got to really dance. A lot of homies. But it really works. Yeah.
Couldn't they just light like a big ass fire too?
I suppose so, and that's why so many lightning strike fires in the Sierra put themselves out.
So it's kind of like a chain reaction once it's sparked it.
It's exactly a chain reaction. Yeah, you have to spark it. Where, yeah, the lightning will start a fire. That fire will make clouds, and because lightning is often associated with a high moisture buildup, because it's a high temperature, high moisture air mass moving up into a cold atmosphere that makes the lightning, you've got the moisture present. So usually lightning strikes on the front range put themselves out, on the back range they don't. Isn't that neat? I want to say some nuclei. You're all floored. Thanks, everyone. Okay.
Where the Mount makes here.
I don't think so. There's something about the. There's something about. There's something about the differential in air masses, where they have very distinct temperatures and very distinct moisture contents. Storm systems here are really unique. We're basically in the ocean. So we're like in a cloud already. Because we're so close to the ocean, our atmosphere is the same as the rainstorm. You ever notice, like right before a rainstorm, a lot of times things will get wet and hasn't even rained yet? Because the moisture content is so high in the air. Also, our rainstorms are at different altitude. So we're like the first storms that hit land. So basically, like, this is just like surface water hitting us. The storms in the middle of the continent are very different. Okay, so we got our evaporation. Now we're talking about condensation. I'm glad we could do that. The precipitation thing, I got nothing to say. It's just rainfall. Now I got a couple more terms that you might or might not know. One of them is infiltration. If you've ever seen a crappy television show about spies and stuff, people going undercover, what does it mean to infiltrate the drug cartel, or infiltrate the terrorist cell, or infiltrate the government of the rogue state? Yes, to make yourself a part of something else. Yes, that's right. It's to enter that team. You understand that? It means to infiltrate. So when water soaks into the ground, that's called infiltration. The water, it sneaks in. I mean, were the chickens so happy to see you?
Yeah, they have water and everything, but they're like,
Hey, they're laying again.
what,
Legend has it that they're laying again.
really? But yeah, they love the food you bring.
Yeah. My children don't, that's why I bring it. Okay. No, he's not joking. We keep on. Okay. That infiltration is the water that didn't run off in the first place. What do we call that water that runs off?
Run out.
All right.
Doesn't that create the watershed?
Okay, so a watershed is the land which drains to a common point. Just like a basin drains into the drain at the bottom, you know, basins and drains, that whole thing's a watershed. A watershed is the land with a single drainage point. So you could say all of the land that goes to the Pacific is the Pacific watershed, because the Pacific would be the drainage point. But you can also say the Rogue River watershed. That's the part of the Pacific watershed that drains to the Rogue River before going out to the sea. Yeah? So there's little watersheds and big ones.
That's like the lake, that's how
If it was a lake, yes. So that's called the Arroyo Burro watershed, because all the way up to the ridge line, basically over to like Cedar Trail kind of, and then all the way that way to like West Bowl, like paragliders, 154, basically between 154 and Cedar Trail, all the way down like the San Roque Hood, I think. Yeah, San Roque Hood. Down like Las Positas, out to the ocean. Anything that's on that surface will go to that Arroyo Burro Creek, and then it goes out to the ocean at Arroyo Burro. So that's called the Arroyo Burro watershed of the Pacific watershed. Okay, So infiltration is the stuff that wasn't runoff because it's soaked into the ground. Finally, there's a very dorky word that matters a lot. Students, how does a coffee percolator work? How many of you make your own coffee? The rest of you pay some guy with a dorky mustache?
No.
How many of you don't drink coffee? Oh. That's news to me. Wait, like never drink coffee? Not very often. Ah, daily. Come hell or high water every single day. Huh. Interesting. Dude, I realized recently that coffee is my only unbroken addiction. Ever since I was a really young child, I pretty much like had coffee every day. In Argentina, we start very young. Like literally, I would get home from elementary school and have my coffee with milk every day. It's different, you know. It's like cafe au lait, not exactly like it. But you know, it's espresso au lait. All right, that was fun. Anyway, how does a percolator work? Little trip down memory lane. Feinberg, how does it work?
Kind of like opened up the bigger particles for the liquid so fast.
No, that's what the filter does. Yes.
It boils the brew through and like cycles through.
Kinda, yeah. So that's like a single pot, like a stovetop percolator. Anybody ever seen those plastic ones that are kind of like a funnel and you put it on top of a mug? How does that work? That's a liquid pass through. And what happens? Does the water come out all clear and crystal normal water? Does it come out something different? And then it comes out, you know, stinky and weird, caffeinated and stuff. Percolation is the process of the liquid moving through a solid, moving around little solids. So in coffee, that water pours through a bunch of grounds and makes stinky, weird chemical coffee. Yeah, you know, like it, like, you know, percolates. I don't know. I can only do so many different ways here. I'm sorry. Yeah, so the hot water goes through the grounds, and then there's a reason that I use coffee in particular, because you know that water doesn't come out the same as it went in. It's also true, and you may want to write this down because when I get back to it, it will be rushing on the last day of the unit. But when water goes through the ground, just like coffee, that water changes a little bit. In groundwater percolation, it changes biologically, it's filtered mechanically, it changes chemically. So it's important to point out that the same way that the water becomes coffee, surface water becomes groundwater. And they're technically a little bit different. In the case of groundwater, you could pour coffee and water would come out the opposite end. It's like backwards. Water goes through the grounds to make coffee. Coffee goes through the ground to make water. Yeah, really. Because in the groundwater, it filters very carefully. It's bioremediated so that living stuff will suck out a whole lot of the chemistry. And you pretty much just get plain old water down there. So I think we've covered some really basic vocab. Runoff, condensation, nuclear, precipitation, infiltration, percolation, evaporation, transpiration. One thing I'd like to point out now that I'll get back to in a minute, please look up. The water in the ground is called, and that stuff pours through in all sorts of different places. That can evaporate back out to space, it can go into plants, it can pop out into surface water. or it can flow unseen into ocean water. Does that make sense to everybody? So next, in the other half of number 11, I'd like to talk about that groundwater. Pretty much anywhere you are on this planet, if you're on land, there's groundwater underneath you. With a very, very, very few exceptions. Does anybody know what exceptions those are? Where could you stand on land and not have groundwater under you? Someone said what? A volcano? Yes. Because you're literally, you would be on rock, and underneath that there's presumably magma, or you're on the magma. Where else?
It's ocean water.
No, I'm going to assume that there's water underneath the stuff at the bottom of the ocean for the most part. So your ice, ocean water. Wait, Antarctica has land. The Arctic doesn't have land. So if you're at the North Pole, you've got ice, ocean, and then sediment with water under it too. The only other place is exposed bedrock, such as Half Dome. If you're standing on top of Half Dome, there's basically solid rock and like 10,000 feet deeper magma. What?
Why is that?
Because every now and then, in the places where the plates collide, they stack up. And by stacking up, glaciation will scour them of organic material and literally expose the bedrock underneath the organic material. So there's no ground for the water to be in. Anyway, everywhere else there's water. So right here there's water under your feet. I can't get an exact number. If anybody has it or can find out, I'd love to know. I think we're somewhere around 50 feet above sea level right here. It might be 30 feet. I know it's more than 20, and I'm pretty sure it's less than 70. So I'm not exactly, I don't know. I have a thing on my cell phone that figures out my exact elevation, but it doesn't give me my elevation very accurately here. If somebody wants to try the Google Map thing, that might tell me. I mean, will you Google Map and find out my elevation? Are we already on that? Thank you. Okay. It's so good. If we go all the way to sea level, do you know what's underneath us at sea level?
Water.
The sea. And stacked on top of that is a layer of fresh water that's like rushing into the salt water. Wherever we are, there's groundwater underneath us. And I want to talk about that groundwater. Like you can see there's just groundwater wherever you are. Up in the mountains, like on West Camino where I used to live, that groundwater is above where we are now. It's just pouring out to the ocean slowly. You know what I mean by that? Okay. First, some vocabs. Please look up. I think you all have experience with like cups and straws and soda, fountain drinks and ice cubes and lids. Okay.
It's a good question. Is that why, like, on Castillo Street, like, you know that underpass
Yeah.
on the freeway? Like,
That's why.
it's like underwater.
Yeah. That is a good question. So, that's people say it's below sea level. It's not. It's just below the water table.
Yeah.
It's above sea level. But the groundwater is exposed there, especially when there's more groundwater in the ground.
57.1 feet.
57.1 here? Thanks, honey. What?
How do we fix that?
Well, you just have to pile up rocks to get above the water table, but you can't lift the bridge, right? So it gets too tight for trucks to pass through, and if they can have trucks passing through, then you got to reroute trucks, And the city can't reroute the trucks and put up signs that say no trucks here. So because we can't figure out a way to get the trucks through, we just like gave up. Like, all right.
It's like good now. They did all the trick stuff.
I don't care, like it doesn't bother me that it gets a little bumpy or a little wet, but civil engineers do not consider it good.
Well, it used to be like pretty like bad.
Bro, I know when it was asphalt,
Yeah.
they would keep laying asphalt, and
Well,
they'd
they
be like,
tried to like
hey, Ray,
they would put in like electric plates to like evaporate the water or something like that.
For real?
Yeah.
Yeah.
They like did a whole bunch of stuff.
Didn't know about evaporating the water, but that's another interesting option. Alright, back to me. Imagine that those ice cubes in that soda is just like the earth. You've got like much smaller ice cubes, we call them like dirt and sand and rocks and stuff. And then instead of soda, we've got water. Please look up. The water that is fully saturating ice cubes, like with no air pockets, that's called groundwater. It's the water under the ground where it's saturated. That saturation thing's important. It's also called the zone of saturation, where you've got water with no air pockets. Water with no air pockets. It's important that it not have air pockets. I mean, that's what groundwater is. As opposed to, please look up, places that are below the surface where the water is still percolating, that's called the zone of infiltration. Or there's another term, I think it's called the vadose. Zone, but I'm not sure about that. You might want to put a question mark in there. And watch me. The ground which holds the water is called an aquifer. That refers to the land which is full of water. Aquifer is a geological term. It is the chunk of the planet that is full of water. An aquifer is like the cup and ice cubes. There we go.
So, the zone of infiltration is like still underground to the airport.
Before the water's squeezing deeper. An aquifer is the dirt that holds the water. And this is the tricky distinction where my students all fumble. The water table, please look up, is the surface of the groundwater. In other words, the place where it goes from air pockets to no more air pockets. That's called the water table. It's the top of the groundwater. And the top of the groundwater is not flat. The water table is uneven. This is the part that really blows minds, and so I'm going to talk about that more in a minute. I got to remember to do this in very careful order. Did you know ones? Awesome. Thank you. Spectacular. Fabulous. Spectacular. The water table is not level. The ocean is level. Aside from like the subtle effect of the moon's gravity, which creates the high tide or the low tide, the ocean is basically level. Minus little wind chops and ripples. But groundwater is not. We gotta go back to the bathtub for this conversation. That's right. tear in Martin's eyes right now. I'm clothed, Martin. I'm clothed. So Jose's in the bathtub with his clothes on. Chill out. Smile at me. And in my bathtub, I got a little thing in the bathtub. Water surface. Now watch me. I grab my scoopy scoop, fill it with water, and then take it out of the bathtub really, really, really fast. Have I left a hole in my bathtub? Yeah. Everybody goes, no, but you got it right. For like a split gazillion of a second, there actually is. If I could move this fast enough, which is going to be a challenge, resistance and whatnot, but if I could accelerate that water movement beyond what is logistically reasonable, for a split second, you would see a depression in the surface of the water. It's so fast that usually you wouldn't notice, and then what happens? Right, yeah. Yeah, absolutely, absolutely, yeah. In that moment of displacement where you make that ripple, you literally made a dead. But everybody knows that doesn't last very long because, like fluids and pressure in all directions and equal force acting gravity at the same distance from the core of the Earth, yeah? It flashes itself out, we're all okay with that? And also, if I'm playing in my bath and I have a cup of water and I pour it into the bathtub, does that make a pile of water? Yeah, so not really, but yeah, for a split second. The difference is that water will level itself very quickly, whereas water that has to rush through the earth is moving more slowly. Because, working its way through sand isn't sudden. You understand what I mean by that? That infiltration, that movement through the rock, that's slow. So, you get what's called a recharge mound, which is the pile of groundwater that's slowly leveling itself. You gotta know that term. And where you remove groundwater, you get the best vocab term of science, the zone of depression. Yeah, exactly, which is a means head all the time. And wait, it's not the zone, it's the cone of depression. Even better. Like the shame cone you put on a dog when they get surgery. Cone of depression, yeah. Because it's three-dimensional, it's cone. Yeah, bro.
What's that, a recharge one?
Recharge mound is where the water's all piled up in the dirt. And cone of depression is where the groundwater is missing. The water table is flattened out. You see, the thing I have to emphasize now is that the water table is not flat. If groundwater is higher in a means corner of the classroom, then the water table will be slanting this way as the water pours out. And if there's a bunch of recharge happening over here, like a lake where that water percolates through all in that one spot, then we'll have a recharge mound. And then, if there's like a well over here where the groundwater's getting sucked out, you'll have a depression cone. And as it's flowing to the ocean, if there's like a high spot in the bedrock, that groundwater will kind of like rush up a little bit on its way down to the ocean. Yeah.
So you're on the inside, like there's like the water underground, is that affected by the water?
Theoretically, if there wasn't all this dynamic stuff at the surface, sooner or later it would all level. Like if we truly shut off all the rain for eternity, the oceans would fill up a little bit more, and the ground would eventually drain to sea level, which would rise a teeny bit, and then we'd be done. I did. What did you ask me?
So basically the reason that it's not level underground
It's moving more slowly than when Jose was playing in the bath. When you play in the bath, it still has to move. It just moves more quickly than your eyeballs can usually capture. You know what I'm saying? Because there's no resistance, it's just the air. The water's really dense and the air is not. So it levels every time. That same thing's happening in the ground, it's just much slower because there's all the freaking ground in the way.
Recharge mound is the recharge zone.
Yeah, so the recharge zone is the part of the earth where water comes in. Recharge mound is the hump in the water table. Has anybody ever made a hole in the sand near the beach and eventually you hit wet sand and you can make it deeper, you've got a little pool of water? Okay. That's one of these, please look up. It's a discharge zone. And sometimes there's like cracks in the crust where the groundwater is surfaced and they make a stream. That's a place where the groundwater gets to come back to the surface and spill out, where the surface of the earth is below the water table. Yes, or an effluent stream. Those are usually year-round because groundwater has a lot of lag time. Did you find those in like a certain yeah, you find them a lot in foothills of mountains because mountain makes groundwater move more slowly. Right? Does everybody realize that both of these waters are on the way to the ocean? Surface runoff goes really fast because it's like my bathtub. That water goes all that to the sea, and underground that water's just doing the same thing. It's just really, really freaking slow.
The old groundwater goes here.
All groundwater's on its way to the ocean, just like all other water's on its way to the ocean. And to answer your question, Tim, if you have a mountain range that's going to trap a bunch of rain, that's going to percolate into the earth of the mountain, and then that's going to hit groundwater and spill down toward the sea through the ground. And usually, where that levels out, any hollow spots in the dirt, like where a surface stream has scoured some of that dirt, the groundwater is going to be so close that you'll see it surface. So usually in foothills you find springs. Yeah.
Why isn't Death Valley just a big lake?
It kind of is. The salt flats in the middle of Death Valley are. Underneath that salt there's water.
Yeah,
It's
but
just that the evaporation rate,
it just evaporates into it.
right, and so it's just another variable in this mix. If you could shut off the evaporation rate, that water would
So
fill.
like, if it was colder in Death Valley, that would just be like a big lake.
Guess so.
So
Yeah, I'm gonna go yes. If the planet was colder generally, it would be. So, you ever driven to Vegas? A place called Zizix?
Yeah.
It's like ZYZZX.
Sure.
Really, you know what I'm talking about?
No, but just continue.
There's a big ass salt flat on Highway 15 near Barstow.
Yeah.
You go past that railroad car McDonald's on Highway 15, and then there's a huge salt flat to the right. During the last interglacial period, the warmest time between ice ages? No, during the last ice age. Yeah, during the last ice age. That desert was cooler, and it was like a big vegetated forest, and that was a giant lake. And you can walk through the salt flat, and you can mine the salt for lake fossils, like fish and stuff. Yeah. Maybe 15, 16,000. Read that poster. During this period, Barstow was a rainforest. So whatever that says. Okay, so we got our water table, recharge zone, discharge zone, influent stream, effluent stream, aquifer, cone of depression. That's most of the vocab. We got our 11, we got our water basics. Number 12, please look up. This is how much water we have on the planet. Sure, throw my chair at you. It's a heavy ass chair. This is our planet's water. You know how we talk about how our planet's like 78% water and there's so much water and water is the stuff of life? I'd like to counter that by pointing out that almost all that water is toxic to life. And things which are adapted to live in salt water, for the most part, have systems that lower the amount of salt in their cells to roughly the same as yours. Salt is actually pretty hostile to life. And so most of that salt water is not that nice. Please look up. Most of the remaining water is ice. Most of what's left is underground. So what you and I consider actually the stuff of life, what you and I need to irrigate our crops, to drink, to slip and slide, all of that water is basically these. A teeny bit in lakes, a tenth of that jumbling around the atmosphere that hopefully we are crossing our fingers will become our own rain. Depending on where you live, a very small percentage of that atmosphere becomes your rain. There we go. And a much smaller volume of that is actually surface flow. We try to get a scrap of that groundwater, yeah. But the scary thing about groundwater is it's not necessarily distributed where we are. And remember, because of how fast it moves, there's a flow rate issue where, like petroleum, we can suck it out way faster than it recharges. So that number is going down. And after we're done with it, this number is going up. Even if we could access all the groundwater on Earth, we're talking about less than 1/3 of 1%. There's only one reason that I include this study goal. Well, two reasons. The College Board has asked about the saltwater volume. Second reason that I include this. I don't know about you, but I always get this impression like, oh, there's water everywhere. Water's, we got this. And basically all the life that you ever interact with is just juggling this little bit. To me, that really changes things. I don't know. Like, I think about it differently when I realize how rare it is. Yeah?
How much is in frozen fresh water? 100%?
All ice is fresh water. So the ice is the 2.15. That's all frozen waters. Because you can't freeze salt water.
Yeah.
When you freeze salt water, you just get the salt somewhere else. What? Yeah, the last three are the ones that we basically manipulate. That's what you and I get to play with. Sometimes groundwater maybe, so the last four kind of. Is that the end? Is everybody packing up right now? Yeah. Dang. Okay, well, thank you. Bye-bye. I'm sorry I did your homework.
Fine by me.
You'll see when you look at the assignment that it's like make sure you know them all, so that if you know them all, you know them.
Yeah, I got it.